Today we have a major problem given the binary matrix. We want to find the maximum area, max area of ones. It should be a rectangle. So, and also we allowed to swap the columns in any time, any number of times. So the solution is, so we have to think about what the possible result can look like. So we see in this like individual columns or rectangles, but how to optimally rearrange So we should maximize the area. That means for the simple case of single row, we have 0, 1, 1, 0, 1, 1. So we can swap any columns. Essentially, we can sort, for example, like this: 0, 0, 1, 1, 1, and then we see that the maximum area became 3. So it was 1 and 2, and this became 3. So sorting is kind of works in a simple case of a single row. Sorting works. Now, how to deal with not single row? For example, we have 2 rows: 0, 1, 1, 0, and the second row 1, 1, 0, 0. So as we can see, it can't be helped. Now let me actually think about different example. 0, 0, 1. Okay, will it work? I'm not sure. Okay, like this. So if we sort the first one, the second one wouldn't get any help from this. However, we see that this column will always be the number 2. This is 1, and this is 0, this is 0. And if we have another 2 somewhere here, like this 2, it would help. So if there's another 2 or more, like 3 for example, then we can stack them together, and the final area would be like this 2, this 3, and the final area is 2 by 2. Now the solution is kind of emerges from this intuition. If we look at the initial matrix, looking at the last row, and we see that there is a histogram of some elements like this. Then we can in the last row, then we can rearrange, and this would look like the sorted version. And now we can think about what would be the bigger, this horizontal rectangle, this middle ground, or this vertical ground. So we just have to compare all of them, compare all, and as they are sorted, we can do this in O of n, because the area is just this value, it is like height, and this is width. And as we go, the height is only grows, is only up, and width is only shorter by exactly position of the x coordinate. And the final formula is the maximum of hx times the total width minus x. So this will be like this, times width minus x. So this is a formula. Now let's look at the code. And I forgot to mention that as we only see the last row, it doesn't matter what's in the next row. So we can just go row by row, and each time we are thinking of this row as the last one. That way we are seeking the best value of all the rows. So now let's look at the code. It's a simple iteration over the rows. Then we have to calculate the histogram, just at +1 if we have the current value, and if we have 0, we should keep it as 0. Then we soften this histogram using a separate. We have to use separate because the column orders matter, and then we have to find the maximum by iterating. Now let's look how this code can be shorter. So the shortest version is this one. We can strip the maximum variable by just taking max off, and we can just use sorted instead of clone. So this is how it works. And another mini like golfing is we can check if y coordinate is not 0 before the for cycle. And also this version of histogram building is kind of nice. We are multiplying the current row by the previous histogram value +1. So essentially checking by 0. So and now let's look at the Rust code. It's essentially the same code. Nothing difference from the program. So that's it for today.